Good afternoon. My name is Cristian Taboada. I'm talking about of the magnetocaloric system. The name of the work is Modification of the magnetocaloric properties of manganese lanthanum strontium by doping with neodymium. The authors of this work is Taboada Moreno, Cristian Antonio, Valerín Miró, Ana María, Sánchez de Jesús Félix, Pedro García Fernando, Cortés Escobedo, Claudia Alicia. The importance of the new system technologic is the great importance because the planet's surface temperature has been increased around 1.2 degrees Celsius. This is promoted by increment in carbon dioxide emissions. Many of these generated by use of cooling system based on compression expansion of gas. In order to reduce CO2 emission is necessary new cooling system with high efficiency, low energy consumption, and friendly to environment. One of the most promising alternative is the magnetocaloric cooling, which is based to use materials that possess magnetocaloric effect. The system of manganese focus its foundation on different systems. One the main is the double exchange, super exchange, and direct exchange between of the ions and manganese and oxygen. This classification is correlated with general rules of Godenau, with which sites and the interaction that can have predicted. The magnetocaloric effect is defined on isothermal magnetic entropy changes on adiabatic temperature changes of magnetic material upon an application of magnetic field. The system of magnetic figures is foundations of different systems of the main games. In this work reports the reduction of temperature on the magnetocaloric materials in manganese lanthanum strontium by doping with neodymium in a rank of 0 to 0.4 mol. The first peak, manganese type Nd3, where the seat is occupied by alkaline and alkaline earth ion indices, the ion transforms the crystal structure about the difference on the ionic radium. The seat B, occupied by the transition elements, will confer the magnetic properties of the material. The magnetocaloric phenomenon works when the material is subject to variation of the magnetic field. The ordering and disorder of the spin on the material conferring these changes of entropy of the materials that with material with a change ferromagnetic and ferromagnetic phase as shown at the temperature around the main. The powders were synthesized by high energy ball milling for 5 hours assisted with heat treatment. XRD results confirm the formation of the structure tetragonal Nd3 by all samples. The content of neodymium. This is confirmed by Rydell, in which there on angles with the manganese ions were calculated with confirmed the displacement with the distances and both angles, with which the crystal structure suffers displacement and the causes the magnetic properties will change. The samples obtained by mechanosynthesis and thermal treatment reveal that doping manganese with neodymium stabilizes the structure in Nd3 for all composition. The magnetic evaluation is the magnetic potential of the samples were evaluated to know their behavior at a room temperature. Avoid that by increasing the medium. Increase the samples, their saturation magnetism decrease. All the samples show ferromagnetic behavior. Their dependence of temperature is what evaluated with determinant is temperature curve. In the magnetocaloric evaluation, an entropy change of 3.72 joules kilogram Kelvin was obtained around room temperature and applied fall on 1.8 Teslas, which indicates that with and this sample working and rank and compassion. Vibrating system magnetocaloric show ferromagnetic order of all samples around temperature. This simple is perfectly for use at room temperature. For conclusion, neodymium, doppel and tandem manganites were successfully synthesized to obtain manganite lanthanum strontium by high-energy ball milling. The magnetocaloric behavior of the synthesis power was analyzed to verify that magnetocaloric response improved compared to the obtained by other methods, and in particular its current temperature, which found in a range of 255 and 364 Kelvin, depending on the level of doping with neodymium. The materials presented entropy change in 0.35 of 3.72 joules Kelvin at 1.8 Teslas. This favors a wide range for use these materials. Only reference. Thank you for attention.